Good afternoon, dear colleagues. My name is Michael Gasanov and I represent the Skoltech Institute of Science and Technology. Today I want to present our research sensitivity analysis of soil parameters in a crop model supported with high-throughput computing. Plant growth and development models are important for both scientific study and farmers, as the use of decision-making systems based on crop models allows farmers to reduce fertilizer consumption and improve crop rotation planning. We suggest that using sensitivity analysis can help farmers better understand what factors affect crop yields. The main factors that affect crop yields are weather, soil conditions, landscape, and fertilizers. Um, we have analyzed the performance of Monica model. This is an agro-system model consisting of submodels such as plant growth model, nitrogen cycle model, crop rotation model, and soil physics model. Significant number of parameters and complexity of the model make it possible to perform sensitivity analysis to select the most important ones. In Monica model there are more than 200 parameters. One of the main parts of a model, the soil model. In the model, the soil block is defined as a setup of layers with different thicknesses. The total depth is 2 meters. A user can set up the depth of the layer and its main parameters. We rated the sensitivity of the model to changes in soil indicator in different layers. We are interested in first, which layer is most important for plants, and second, which soil parameters are most affect the yield of these crops. And main goal is sensitivity analysis of Monica model supported with high-throughput computing. And some objectives: estimate optimal number of samples for sensitivity analysis, determine which soil layer plays the most important role in the yield production, define which soil parameter is the most important in topsoil layer, and speed up the model simulations with high-throughput computing. From various approaches for sensitivity analysis, we choose the Sobel approach since it allows us to evaluate the combined effect of parameters on model result. And to perform sensitivity analysis, we use the CELIP library for Python. And Sobel sensitivity analysis provides some pluses. It's global sensitivity, but there are minus. It's computationally cost. We can consider the result of model as the sum of influence of parameters and the sum of interactions of these parameters with each other. Each variable contributes to the overall variance. We can take into account the contribution of each of the variance caused the change in each of the parameters to the overall variance. Sensitivity indices are defined as the ratio of the partial variance and the total variance. Analysis of sensitivity indices provides sufficient information about the structure of corresponding function. For functions of an additive structure, only the low-order sensitivity indices are important. In extreme case in which there is no interactions among the input variables, all higher-order sensitivity indices are equal to 0. In the general case, all global sensitivity indices can be important. However, for high-dimensional problems, calculating all of them are impractical. For this reason, Sobel introduced sensitivity indices for subsets of variables and the total sensitivity index. The important indices in practice are first total index and total sensitivity index. Their knowledge in most cases provides sufficient information to determine the sensitivity of the analyzed function to individual parameters. Some extreme cases. In case where our first sensitivity index is equal to 0, it means that its parameter doesn't affect output of our model at all. In case where our sensitivity index is equal to 1, it means that result of our model, output of our model, depends only on this parameter. For the experiment, we choose a real field in the Russian region where farmers cultivate crops such as sugar beet, barley, soybean. We measured various agrochemical indicators and parameters, analyzed limits of these parameters for this soil type, its chernozem, For each of the parameters, we looked at how its changes in each soil layer affect crop yields. For example, we see that changes in organic matter content in all layers affect crop yields. For example, changes in the sand content affect only the top layer. A significant number of simulations are required to obtain acceptable confidence intervals. Conducting this number of simulations takes a long of time. For example, running 2 million simulations on a single core took about 1 month. We tried to speed up this process. To do this, we generated samples for the model using Sobel quasi-sequence. For example, for 9 parameters and sample size 100,000, we got a matrix size of 2 millions by 9. Then we divided this matrix into parts. The number of parts depends on the number of cores in the cluster. For example, we used 100 cores. We got the size of batch equal to 20,000. Then on single core, we run parallel models with different input parameters. We joined the obtained results in a single vector and performed sensitivity analysis. Since the parameters in the top layer are most important for crops, we continued research only with this layer. We evaluated changes in 6 different parameters for crop yield. The graph shows the sensitivity indices and their confidence intervals for different sample size for sugar beet. As you can see on the graph, to get reliable values, the sample size must be at least 1000. Only 2 of 6 main parameters affected yield: variability, clay content, and bulk soil density. The yield of barley was affected by changes in the organic matter content and soil density. Reliable results were obtained only as the sample size of 5000. The graph shows results for the entire crop rotation. Here we can see year and type of crops: sugar beet, barley, soybean. Gray circles indicated the indices of the first order. The gray lines on the graph shows a second order sensitivity index, which explains the combined effect of 2 parameters on yield. White circles indicate the total index. We can note for soybean the presence of interaction parameters between each other. We see the presence of total index for organic matter in soybean. This indicates a complex joint effect of this parameter and other parameters. For barley, we can identify a significant interaction between organic matter and soil density. We can also observe changes in importance of parameters for same culture. We see that the importance of organic matter in crop rotation changes for sugar beet over 6 years. Here and here we can see different values for first sensitivity index. It means that with time there are changes in soil which leads to different effect to yield. Our result indicates that for each studied crop, a different set of soil parameters affects the yield. The transformation of organic matter in the soil during crop rotation modifies the importance of these parameters for sugar beet productivity. The results show the presence of collective influence of model input parameters on crop productivity. And thank you for your attention. Yeah, good luck. Stay healthy.